All right. So, all right, let's just quickly, what's our plan today? So we've already talked about an introduction to the course. Now we're going to recap ln and e, okay? Natural logarithms and Euler's number. And then we will start our holiday homework. I don't want to talk too much. You guys are probably pretty keen to, you've probably talked about a lot today, so maybe we'll just get into some work, I think. So, we're familiar with logarithms in base 10, we're familiar with logarithms in base 8. I'm pretty sure most of us have seen this before. This is a logarithm in base E. Alright, so E is what we call Euler's number, and its significance is not so important to us. We just need to know that it's a number and it's about 2.72. It's a number like pi. We call it a transcendental number. And so we have a logarithm in base E. And so what we're going to be doing then is solving problems using both of these identities. All right, so if we look at the first, I'm going to go through, and I reckon I'll do every second letter up here on the board, and then I'll leave the rest for you to have a go at. So if we've got question 1a is ln of e squared. All right, and then our task is to simplify it. So we can see up here, if we have ln e to the x, it's going to simplify to x. Therefore, if we have ln e to the 2, it will simplify to 2. So the answer to the first one is 2. All right, I'll do every second letter. So let's move on to C. All right, we've got ln of the square root of e to the power of a third. So before we can simplify it, we must express it as a single power of e. We need to expand and collect and use index laws such that it's a single power of e. So the first thing to do is the square root of e, that is e to the half. Okay, so we're going to convert the square root of e to the half. The power of 3 is going to hang out there. Okay, then we have e to the half to the power of 3, so we're going to multiply those two powers together. That's to the 3 on 2. Half times 3 is 3 on 2. And so this will simplify to, we've got ln e to the 3 on 2. Ln e to the x is x. So ln e to the 3 on 2 is 3 on 2. Any questions so far? All right, jump ahead to E. All right, we have ln of 1 on top of E. Now, 1 on top of E, the power of E here, anytime we've got a letter written by itself, the power is always 1. And so remember, we can take that to the top and make the power negative, can't we? We can make it ln E to the minus 1. And now we've expressed it as a single power of e, and so it simplifies to minus 1. E so what are we up to? We did A, C, E, so let's do G. G is pretty similar. We've got ln of 1 on e squared. So we're going to take the power to the top, make it negative, simplifies to minus 2. Very good. Okay, on to question 2. Now the only thing to say in question 2 is we're going to be using one of the log laws, which is if we have ln a to the n, we can write it as n ln a. All right, so we're going to be moving from this number out the front and making it a power of a. This is one of our log laws. All right, so let's look at the first one anyway. We have e to the power of ln 3. So in question 1, we're using this first rule. In question 2, we're going to be using the second rule. We have e to the ln x simplifies to x. Therefore, e to the ln3 simplifies to 3. Alright, so that's A. Let's jump on to C. We have e to the minus ln5. Now we can't just straight away simplify that to 5 because we've got this negative out the front. We're going to need to deal with that first. So what I'm going to do, I'm going to write it like this. It's e to the, we've got minus 1 lot of ln5. I'm going to put minus 1 because any time we have a negative and then a term, it just means we've got one lot of that term. And now we're going to use this rule. I have this number out the front, and so I can make that the power. All right, this number 1 out the front, minus 1, I'm going to make that the power. So this becomes e to the ln5 to the power of minus 1. That power belongs to the 5. All right, e to the ln x simplifies to x. E to the ln5 to the minus 1 will simplify to 5 to the minus 1. And we can leave our answer like that, full marks there. Another way to present it, 1 on top of 5. Right, the negative power would go to the, become positive, and then at the bottom. Okay, any questions? Okay, let's move on to E then. We've got question 2E. We have ln e to the a. All right, we've seen this is this question. Ln e to the x simplifies to x. Ln e to the a will simplify to a. All right, clear some space. Okay, and G, we have ln of e to the a times e to the b. So before we can simplify it, we must express it as a single power of e. So we need to collect them somehow. Now they have the same base, which means we can add the powers. This becomes a plus b. All right, the same base. And so we use the index law where we add the powers together. F. Yeah, I'm just doing every second letter, mate. Yeah. Yeah, so you can have a go at that in a moment, or I'll have a go at that in a moment if you want me to put it up here on the board. But yeah, I'll leave that one for you for now. So we've got ln e to the a plus b, and so it'll simplify to a plus b. We've expressed it as a single power of e. All right, question 3. I'm not going to put these up. Maybe I'll do a couple just to talk about significant figures actually. So I'll just say where the ln button is. It's pretty much right in the middle of your calculator, right next to sign. All right, in between sign and log, you'll see the ln button. And the way you get E, the way you get Euler's number is you press Shift ln as well. They are the inverse of one another. So anyway, I'm going to type into my calculator ln12. All right, so if I type in, so which question is this? 3A. I've got ln12, put that in my calculator. I've got 2.4849. Now, the question says 3 decimal places. So if I'm rounding to 3 decimal places, that means I'm going to write 4 decimal places and I round the 4th one. The 4th one rounds up, so that's going to give me 2.485. All right, I'll leave the rest of 3 for you guys. Okay, question 6. In question 6, we have what we call a logarithmic equation. Logarithmic because the variable x is tucked away inside this logarithm. And we're solving a logarithmic equation, we're trying to solve for x, right? Now, remember from algebra, you can do anything to an equation, anything, as long as you do it to both sides. You got to maintain the balance. You've got to maintain the equality. And so what we're going to do is I'm going to raise e to the power of both sides. I'm going to make it e to the ln x is equal to e to the 3. It's still equal. These numbers are equal, powers are equal, the bases are the same, so the relationship maintains. We still have equality. I've raised e to the power of both sides. And now e to the ln x simplifies to x. So the way you think of it, right, is if I've got ln x, the way to get rid of it, e to the power of both sides. That's going to get rid of the ln. Okay, so that's question A. Let's have a go at C. We have ln x is 0. All right, I've got ln x is equal to a number. I need to raise e to the power of both sides. Following that same process. So e to the ln x will simplify to x. And how about e to the 0? Any number to the power of 0 is 1. Very good. All right, so let's jump to F. These are all the same. I might leave the rest of question 6 for you guys to have a go at. Now, you can leave your answer here. You can get full marks there. If you want, you can convert it to 3 significant figures by plugging that into your calculator. Here's fine. We'll just leave it like that. All right, let's go on to question 7 then. And I will do from question 7, I'll do A and C. Actually, maybe I'll just do B. I'll get you guys to have a go at A and C. All right, I've got e to the 3x is equal to 5. All right, so this now, it's different because it's an exponential equation. All right, before we were looking at logarithmic equation because the variable's inside a logarithm. Here it's an exponential equation because the variable is a power within the exponential, right? And so we saw before, if we want to get rid of ln, we put e on both sides. And so similarly, if we want to get rid of e, we just perform the natural logarithm on both sides. Remember, they're equal. We can do anything we want as long as we do it to both sides. So I'm going to have ln of e to the 3x is equal to ln of 5. Now we've seen ln e to the x is x. Therefore, ln e to the 3x is 3x. 3x is ln 5. Divide both sides by 3. X is a third of ln 5. Okay, so those kind of, like I've jumped here, I'm assuming a little bit. We're at the end of year 11 methods, so we're hopefully competent with that. If you've got any questions about that, please let me know. That's sort of still there. But hopefully that, as a recap of tricks, feels okay. As a recap of exponentials and logarithms, feels okay. So I just have a go at the ones I haven't done. Maybe you've done them already, but that's all from me for now, and then we'll just have a go at some of the holiday homework. So let's get into that, I reckon.